Hey guys, as some of you know, I recently took the IRS out of my 2020 Mustang for some upgrades. I have bent and damaged some components. I've been trying to share as much of that information as possible. In today's video, I'm going to show you why I am installing the BMR adjustable camber links with delrin bushings, as well as the BMR vertical links with delrin bushings on the top and spherical bearings on the bottom. I've got two assemblies over here on my truck bed, one outfitted with just basic modifications, the other outfitted with the majority of the modifications that I've chosen to go with. So I'm going to go over those details and then also go over some weight details and additional information. So let's go over to my workbench over here where I've got these components laid out. BMR TCA 046 vertical link. A lot of you don't know, but I was actually involved in the process of developing these and designing them. Matter of fact, they used to have the delrin on the bottom and the bearing on the top, but those made a little bit too much noise. Let me grab a drink of my favorite drink, Celsius. So anyways, here it is. Here is a stock vertical link. It's a stamped steel, P for passenger side, right? I mark everything when I take it out. It's a stamped steel piece. If I remember right, it weighs about 1.5 pounds. Nothing special. You can put a screwdriver in each end and twist it. I mean, it deflects a lot. It does what it needs to do. This is a sticky topic for me because honestly, I've used these stock ones up until now, and I haven't really had any issues, although I did see something when I pulled all this apart. I found one that looks to be damaged, so I'll show you that here in a little bit. If you look down, it's like twisted like this. It's the driver side. Back in 2015, I also bent a driver side, unless they just make them bent. I don't know, but anyways, here is the stock vertical link with rubber bushings. They are designed the way they are for a reason. They need to articulate in this manner right here when they're on the car. Let's weigh this real quick. £1 pound 9 ounces. The BMR, same weight. So way stronger, way less deflection, same weight. Let me go over the details on this BMR real quick. First and foremost, BMR is the only company, and we spent a lot of time when I was there working on this, that has a truly free-floating delrin bushing design. I've never seen another company have a design that will rotate very freely like this. It takes a lot of work because these are a press-fit bushing right here, and all of these tolerances stack up. So the ID of this, the OD and ID of the inner part of this bushing, and then of course the machining of this piece here. So this goes to the top of the knuckle. This goes in the bottom of the control arm. I have it installed over there, so I'll show you in a little bit. But super strong piece. BMR has delrin, and then they have a bearing, and then they have a delrin bearing. So, you know, BMR was definitely at the forefront of coming out with all the different options. I'm actually going to come up with a set here soon that are adjustable, and I'll explain some of the reasons why I'm doing adjustable in later videos. But anyways, I'm not going to carry on too much more about the vertical links. They're a decent upgrade. They don't do a whole lot for wheel hop. A lot of that's smoke and mirrors. Some of the companies out there, especially one, came out like basically saying that vertical links are the best thing since sliced bread, and they're really not. You know, they're a good upgrade for high power cars, so you don't bend and break things, but they don't do a lot for wheel hop and stuff. Now here are the camber links. BMR again, you know, has their very specific design here. It's different than anything on the market. It doesn't have the adjuster in the center here that snaps. Again, I was involved. This design was actually my idea. So the way this works is it has a delrin bushing on the inside with a grease fitting, which is super convenient. On the outside it has A Viking Performance rod end, 3/4. It has this stainless steel beveled spacer, and then this is on-car adjustable, and then a set screw. The stock, once again, has rubber bushings. The bushings on this are actually really similar to the ones on the vertical links. They look the same, and that's because they're designed, you know, for pivot, for rotation. I'm not going to spend a whole lot of time on this, but I am going to weigh them all together. So let's weigh the stock one real quick. 4 pounds 13 ounces. So 1 pound and 4 ounce savings. So now let's put them all together. Let's do the BMR. 5 pounds even. So 6 pounds 7 ounces. So that would be 2 pounds, call it 3 pounds savings basically. So when you do this on each side of the car and you replace replace basically these with those, you're going to save about 3 pounds. So it's not a whole lot, but any of that weight is better than no weight, right? So now let's go over to the assemblies that I have out here, and let me just show you. Oh, it's a bright one out here. So this is the lower control arm. This has the factory spherical here. I upgraded 1,000 miles ago the forward control arm bushing with the BMR BK081. That is a steel machine design with a 1-inch bearing with billet aluminum spacers. I also have the BMR toe links. These have lockout plates here. This is a 3/4 inch rod end female with a chromoly adapter. This is all TIG welded, gusseted, very nice toe links. Definitely my favorite on the market. Now I want to show you, I have these loose. I don't have anything tightened up here, okay? And there's a reason, is because everything on this part I wanted to have loose so you can see the difference between just this. This is torqued to 83 foot-pounds. This is torqued to the same 83 foot-pounds. This is torqued to 129 foot-pounds. This is the driver's side. I was telling you earlier how I noticed, I don't know if you can see here, but I have some pictures. I'll insert them in the video. But this this top is twisted in. This is the second one that I've had do that. I don't know what causes it, but it's only been the driver's side, and it's only been on, you know, 1,000+ horsepower, right? Let me see if I can. It's kind of hard to tell, but it's definitely bent. Again, I'll show the picture. Now on this one, there's my prototype rear diff bearings, by the way. Pretty fancy. This is a new cradle that I got from Ford a couple years ago. It's just been sitting around. This has the BMR Camber link. It's got the BMR lockout, which I try to sell to all my customers. That ensures that there's no slip here, which is super important on an aftermarket Camber link. They all will slip right here, even if you torque this to 85 foot-pounds. Now this has better hardware, so this actually torques to 105 foot-pounds. So not only are you locking this out with these holes here, it gets rid of the slot, but you torque it to 105 foot-pounds, so that is not going to move. This is torqued to 83 foot-pounds. Now this is just hand tight, just to show this example. Again, this is torqued to 129. We got the BMR toe link on this one. It is at an angle because you can't really keep this thing up because it moves so freely. I forgot to tell you also, on the knuckles on both sides I have the Ford Performance toe bearing, just because that's one of the most important modifications to do at first. This is not tight. This is not tight. Okay? So the only thing tight on these, oh, and this is not tight. The only thing tight on these is this, 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 and this, okay? And that's what I'm doing this video about. So what I'm going to show you is, I'm going to hold this, put my weight on this cradle, and push down, it wants to move the cradle. Hold on a second. I can't even budge it, okay? So what I'll do is I'm gonna hop up on the tailgate, stand on this, and pull. Okay, so I'm getting it to move, see it? It's like legit stuck in this 3-inch zone on the outboard side, not the inboard. That's all it will move. If you had that modified or mounted on the car, then what you would do is you would pull this down to about here and it would just shoot back up, okay? The reason is because this rubber and this rubber rotates this way. When this knuckle moves up and down, this is supposed to move this way and this moves this way. Over here, this also does the same thing. When this goes up and down, these bushings rotate. So right now, that's a bonded bushing, that's a bonded bushing. This is bonded, this is bonded. So it does not want to move at all. Again, it'll move a little bit, but it goes right back to place and it's held up like this, watch. Okay. Now let's compare it to this one. It's already sagging down, right? So do a quick pull up on it. I just pulled it all the way up there, watch. See that? Pull it up again. See if it'll fall naturally. Yep. And then watch. Look at that. No force at all. Just a touch. So this is a delrin bushing, non-bonded. This is a spherical rod end. This is a delrin bushing, not bonded, free floating, and that's a spherical. Then you can see that it's rotated. See the angle there? So straighten it back up. And watch it. See how nice and smooth that is? So again, all the components are loose except for the camber link and the vertical links. That's it. And again, you see this one sagging. So look, there's that one stuck in its position. This one's just dropped down. One more time. It rotates very freely. Now, we've gone over this. Let me just tell you why this is important. So this is important because your shock, okay, your shock mounts here and it goes up to the chassis up here. Every time this moves, the shock is responsible for controlling the rate at which it moves, okay? The spring has a spring rate. The spring sits here, so the compression is determined by the spring rate of the spring. The shock controls that wheel rate movement, okay? So when you have these rubber bushings in here, what that does is it adds to the stiffness of this spring, if that makes sense. So if I push this down 3 inches with 75 pounds, right? it felt like it may take a little bit more than that. So if I push it down and it takes 100 pounds to compress it 3 inches, but then at that point, let's say it takes an additional 100 pounds, okay? So then you just do the math. So it took 200 pounds to move it 4 inches, for example, just something like that. We're just using rough numbers here. So you have a certain amount of weight to compress the suspension a certain distance. In this case, we'll just say pounds per inch. So 100 pound per inch spring, it takes 100 pounds on top of that spring to compress it 1 inch. So that compounds. When you have the amount of force it takes to compress this and move this suspension, it's adding to the work that this shock has to do. That's why you'll hear people say they have shocks that are under-dampened or over-dampened, or springs, etc., that are under-dampened or over-dampened, is because they don't have dampers that can control the rate of that spring. So the reason I'm going into this is when you have a setup like this that moves freely, it doesn't add any type of artificial spring rate or wheel rate, okay? It doesn't put any more rate at that wheel. It doesn't take any more force over your spring to make that compress. Whereas to this setup, you can see it's stuck in this position, right? This one, my wife's trying to show off. This one will actually take more force to compress this. So that's going to be, for example, like at the drag strip when a car squats like 2 inches. When this suspension right here squats 2 inches, it's going to be a free squat, and it's going to have superior control from the shock, where this one is not, because it has that additional force or that fake spring rate, okay? And you'll see some of the companies talk about that on their vertical link advertisements. They'll talk about how, you know, replace the factory vertical link with an aftermarket to remove that artificial spring rate. So all of these modifications that have bonded rubber bushings, again, are adding artificial rate. So it takes more force to move this than it does to move this. So then that changes the whole dynamic of everything. Some of the things that also play a factor here are if you have less wheel rate here with this suspension, then and less deflection, then your sway bar and your shock and everything else will work a lot quicker and sooner, so it will respond and react quicker because there's no deflection before it hits that shock. So just like a shock, the companies that have aftermarket shock mounts, so the shock goes here and it comes up to the chassis. Well, there's companies that have the upper mounts, they get rid of the rubber. And what that does is as soon as the suspension moves, the shock can control it instantly instead of having to go through that deflection of that rubber before it can control the movement. So the same thing applies here. That's why this upgrade right here is so important. This upgrade and this upgrade, the toe. The first three modifications that I always tell people are like a Cradle lockout, my posi lock kit, a BMR lockout kit, etc. The control arm bearing here, I'm a big fan of the BMR BK081. That's what I use on all my cars. I've used the BK055 as well, but it's a little too stiff for me personally. The BK081 lockout and the toe bearing, the Ford Performance toe bearing is a M-5A460-M part number. Those are the first three parts. Those are the best parts. That will eliminate this movement of this cradle. That will eliminate this movement of this arm, which is a ton, and it will also eliminate your toe deflection changing alignment. So all three of those help control the geometry better, and they also lead to less geometry change under heavy loads. So again, this knuckle assembly has the stock stamped stock rubber bushing stuff attached to it. We can barely move it up and down. Okay, this one has everything's loose except for these components. This one has the BMR TCA 046 delrin bearing with the BMR Camber link, which is a UCA 763 with delrin bearing, and it just moves very freely. Okay. Now I'm going to continue to do these videos as I do upgrades. One of my favorites here is this prototype kit that I'm testing. That's the stock rubber bushing. Mine had that damper here, and then here is the new Kel-Track diff bearings. Now on the fronts, I'm going to keep them stock. And then what I'll do as time passes, if I notice that I need something more than stock, then I'm going to make little inserts that go in these holes. Let me see if I can see those holes. I'm not going to replace these. I just have too many issues with replacing the front bushing. So bearing in the rear, bushing in the front. You may ask, why do that? Well, my theory here is, since the rear can't fall down, it can only pivot, then it's going to lift equally on this front bushing instead of do this. Look at that. See that? So because the rear bushing can collapse and come down to here instead of just pivot here, then what it does is it wants to pivot this, it wants to pull down on this like this. But if you were to have a bearing here, like my other cradle, then it rotates on this axis here and it will lift up on this. Instead of twist down, it'll lift up. That's why I have this bolt on the other side. So basically, if you were to lift up on both of these, you can barely depress this, you can barely move that bushing, compared to if this were to drop down and then put twisting force on it. Like I said, it's super easy. So my theory is that the bearing on the back here will make that front bushing work better, and it'll allow people to have a better performing you know, rear suspension and a diff with less noise than a solid replacement. All right, guys, I gotta get, thanks for watching. I just wanted to kind of go over the reasons why I chose to use the BMR camber links and the vertical links. And like I said, I'm not usually a big fan of upgrading the vertical links because they don't really do a whole lot. But in this case, I wanted to show you what they do when you do install them. They help the suspension move. Notice I'm not going to sit here and talk about wheel hop and stuff, because that's all smoke and mirrors. Like when these companies come out with, one company in particular has like multiple stop the hop levels and stuff, and they give you like, you know, these centering sleeves, right? So they'll do like, you know, stop your wheel hop with a centering sleeve and a vertical link and a brace that attaches to like the middle of the cradle here, not here, not here. Like they have stuff like that that's all just smoke and mirrors. It's honestly just marketing hype. You don't get that from me. I went 146 60 foot with this suspension setup right here. Stock camber links, stock vertical links. The only thing I had was this, my Posilock kit. I did have these in here just because I don't want to keep on aligning the car. And then toe links. That's it. I didn't have all the crazy, you know, I didn't have all this, I didn't have the full setup. I just had really basic mods and stock diff bushings. So MT82 car 9s, the very first pass I made, 146 60 foot, a 147, a 148, and a 149, I believe. I cut it all. But 146, mostly all stock. Control arm bearing, a lockout kit, and toe links, because I hate when the toe slips. But this is the actual cradle with the ripped bushing. This is the one that I had in my last video. All right, guys. Until next time.